Hi everyone, welcome back. This is the 39th video in our series on building a chess engine from scratch in the Java programming language. Our focus has been on the GUI, and in the last video I did about 90% of the work to basically to support the taken pieces panel here on the left, and we'll do a little bit of cleanup in this video on some of the technical that I created in the last video, and we'll also see if we can start to flesh this panel out here. Once we do that, most of the GUI is built, and we can go back to things like en passant and other interesting parts of the game like the AI. We've accomplished a lot in what's almost 40 videos. But I think that I want to say that I appreciate everyone's patience. If you've actually gotten this far and you have built things out or paid attention, it's not easy to build a game like this, and it's taken a lot of work. But I think it's going to pay off in the end. So, right, let's jump right into it. So I think in the last video, right. So if we look at the taken pieces panel. I don't have this method defined, so I have this compilation error right now. So let's see if I can deal with that. Let me expand this just a little bit. Alright, so this method, this is saying that this method doesn't exist. So let's click into piece, and what we're going to do is we're going to introduce that method. We're going to say that there's a public method called getPieceValue, and it's going to simply delegate to the piece type. Okay? And obviously now we see that this method doesn't exist on piece type, so we've got to go to the piece type enum, and in here what we're going to do is we're going to have a method on here called public int getPieceValue, and we might in the future make it such that that's not public, but for the most part we can ignore that right now. Right now we're going to say return this dot piece value. And what we will do is we will, for the constructor, we're going to pass in an extra argument, and that additional argument is going to be the value, if you will. So okay. Oops. Okay. So now notice that all the enums are broken here. And I don't want you to focus too much on the actual values that I'm going to type in here. That's going to be really for a future video. Explaining that is going to be part of the AI. The one thing that to just keep in mind is that, right, so the pawn is going to be sort of the least valuable piece. The knight and the bishop are going to be equally valuable. The rook is going to be slightly more valuable than that. The queen is going to be slightly more valuable than that. And the king is obviously the most valuable piece in the game. Okay? So I'm going to assign a score of 100 here, 300 to the knight, 300 to the bishop, 500. If any of you have done chess programming, you're sort of familiar with these numbers. 900, they're heuristics, right? And this is going to be something like 10,000. Okay, so that should get rid of the compiler errors that we had in here, and that's a good thing. And we're not using this anywhere yet, right? We just sort of fleshed this panel out, but we haven't hooked it up in our code. So what we'll do now is in this video we will build out the game history panel. So let's go to that class. Here we're going to say new, Java class, and we're going to call it game history panel, and we're going to extend from jpanel. Okay. And this is going to require, a little bit more understanding on the GUI stuff. You're going to have to sort of know the model, the data model kind of aspect. I'm not going to go over it too much. If you guys end up with questions, you can ask me or look through it. It's not, in my opinion, the most interesting aspect of a chess game. It's just sort of GUI code. So you can use it and step through it and debug it, but let's just start to flesh it out and see what we get. So we're going to say game history panel, this.set layout to new border layout. This.model is equal to new data model. Okay. Let's final data model is equal to model. You'll see what this is. It's going to be something that data model. This is going to have to be something that I create via extension. Final JTable table is equal to new JTable model. So we're going to be using like a JTable, which is sort of like, it's sort of like a table in Excel. Table.set row height to 15. This dot scroll pane is equal to new JScroll pane. And this scroll pane is really going to allow, it's going to account for, it's going to be sort of like if the number of moves exceeds this window frame, it'll create a scroll panel, and that scroll panel will let us scroll through all of the moves, right? So table, let's declare private final JScroll pane. Scroll pane. Okay. Scroll pane dot set column header view to table dot get table header, and this dot add scroll pane, and this dot set visible to be true. We're going to add this here to border layout dot center, and we're going to set a preferred size. Just bear with me. History panel dimension. One 400. Okay. So we're also going to have a method on here called redo, following the same pattern. And we might even create an interface later that's called like redoable. Void redo final board and final move log. Okay. All right. So is there any other method that we're going to have on here? Yeah, we're going to have a few things on here. So let's create the data model. So if we want to use a JTable, if you want to learn about data models, you really need to focus on studying how to interact with JTables in a way that's not trivial, right? If you want sort of a non-minimalistic JTable, then it's recommended that you do it through these data models. And so So let's see if I can, let's create mine. So private static class data model extends default table model. Default table model. Okay, that'll get rid of our compiler errors. And what we're going to do, we're going to have a couple of classes here. We're going to say our table, the data in our table is going to follow this format. List of rows, values, and private static final string name. You know, this could be headers, but we'll just call it names is equal to white and black. Oops. Okay. And really what we're going to want is one more class here called private static class row. That's what that row is going to represent there. Let's, there we go. Without complaining about. Huh. What? Using anything in AWT there? Let's try to fix that again. I hate these auto imports. Okay. Variable values might not have been initialized. That's better. Okay, so, right. So, let's look at what a row is. A row basically is going to consist of private string white move, private, this is where it starts making sense, string black move, I'm going to say row, right, public string get white move, return this dot white move, public string get black move, return this dot black move, public void set white move, final string move, stop white move is equal to white move, public void set black move, final string move, this dot black move is equal to move. Okay, that's really it. Okay, so really what we're just capturing here is, you know, I make this move, I make that move, that's a row, right? This is the header, the name, and there's a full row right there. Okay, so that's what we've done here with this row class. So in our data model, let's come up here and say data model this dot values is equal to new array list, and that's it. And let's make some methods on here. Let's say public void clear this dot values dot clear, and set the row count to 0. This is a method, yeah. So let's start overriding the methods for the default table model. Public int get row count. This will tell the model, right? By extending the default table model, we're basically, Swing is going to invoke these methods. Swing is going to invoke methods that we are overriding here that are going to tell it how to render the table. And one of the important methods is get row count. So we're just going to say values is equal to null. Then return 0. That means there's no rows yet. And otherwise return this dot values dot size. Okay, simple enough. override public int get column count, and we know what that is. That's just going to be 2, but we can actually make this more intelligent and say return names dot length. Okay, it's going to basically be, but that's 2, right? So, and here's another method called get value at that needs to be overridden. Public object get value at and final int row, final int column. This is, when Swing needs to render one of the cells, this is going to tell it how to retrieve that cell on the given row and column. Current row is equal to this dot values dot get row, and if the column is 0, then return current row dot get the white move. Otherwise, if the column is equal to 1, then return current row dot get black move. Otherwise, return null, which I don't think you'll ever hit that case. So again, this is a method that Swing is going to invoke. Now we need set override public void set value at final object value final int row, final int column. Okay, I know I'm blazing through this rather quickly. It's because I kind of find this code to be not that interesting. Final row, current row. Right, so if this dot values dot size is less than or equal to row, then current row is equal to new row, and this dot values dot add current row. Okay, else current row is equal to this dot values dot get row. Okay, and if the column is equal to 0, then current row dot set the white move to be a string of a value, the string representation of a value. Else, if column is equal to 1, then current row dot set black move to be a value as a string. And finally, fire table cell updated row and column. So you definitely have, if you really want to understand what's going on here and you don't, you're going to have to read some Swing tutorials on how JTables work and the model pattern. I think it's probably if you don't know it, you kind of understand, what I've done, but it would really be valuable for you to look that up on your own. It's not really too pertinent to building the chess engine. It's just sort of a nicety, so I'm not going to spend too much time on it, but this should work. Override, there's some other override methods we need, like public class get column class, final int column, return move dot class, and override public string get column name final int column, return names dot, off of column. Okay, so that should be that. Now we have all the pieces that we need from our model in order to do the execute the remove, the redo, the redraw. Okay, so when we come to do the redo, then what we're going to say is int. This is going to redraw the entire panel here. We'll say int current row is equal to 0, and this dot model dot clear. And for final, move in move history, or I'm sorry, move log. Let's call this move history just to be consistent. Move history. Dot get moves. Final string move text is equal to move dot toString. If the moves get moved piece dot get piece alliance is white, then what we want to say is this dot model dot set value at move text current row 0. Okay. Else if they move dot get moved piece dot get piece alliance is black, this dot model dot set value at move text current row 1, right? So the only thing is, the only difference is that this is column 1, this is column 0. So when we're white, we want to place this move text here. When we're black, we want to place it here in this column. That's all we really said there in that loop. And after we're done with that, after we have done the second column, we want to say current row plus plus. We're done with that. And if the move history dot get moves size is greater than 0, right? Final move, last move is equal to move history dot get moves dot get move history dot size minus 1. This is the last move that was made on the board. Final string move text is equal to last move dot toString. And if the last move get moved piece get piece alliance is white, then this dot model dot set value at move text plus. So really what we're doing here is for the last move, we want to calculate whether we should put a plus or not. So in the game of chess, right, if, for example, here, let me show you this. If we said, I don't know, let's move the king up here. That's kind of a dumb move. Let's do that. And then if we did this, notice that there's a plus here. So not only did we emit the move text, but we, by making this move, right, we know that that move placed the king in check, right? So all we're doing is, since we're not keeping track of that in the move, we're not keeping track of whether the move is a checking move or not, then here in redo, we're keeping track of that. There's different ways we could do it. But for simplicity, the way I've chosen to do it is to do it in a method. So what we'll say is move text plus calculate check and checkmate hash on the board, and current row minus 1 and 1. This is going to be the row in the column that we put that in. And after we do that, we're going to have to make that method. And then we're going to say final j scroll bar vertical is equal to scroll pane dot get vertical scroll bar, and vertical scroll bar dot set value to vertical dot get maximum. So all this is going to do is if the number of moves that we have exceeds the scroll panel, it auto advances down to the last move, right? So, and in this method here, let's create that method. Let's just say if, let's make it real easy. Let's say if the board's current player is in checkmate, return, this is the convention in PGN. You can look it up when you're in checkmate. Else if the board's current player is in check, right? And the order of these matters because you can be in checkmate and be in check. So you want to put, if you're in checkmate first. So if you're not in checkmate, then we'll come here. But you are in check, we'll say return check. That's the symbol for check. Otherwise, just return blank. Okay. Wow. That was a lot, and I blazed through it. In the next video, I'll come back and I will hook this up. Obviously, look, I've got these warnings in here that are telling me I've got unused imports and I don't know what else. Most likely, just I'm not calling these methods anywhere, right? That's what it's telling me. We'll come back and we will hook that up. And what we'll say is that the GUI, for the most part, is functional. Then we'll go back and we'll do en passant the special moves. We'll do some basic unit tests, and then I'll point you guys to where all my unit tests exist, and you can import them and run them and make sure that the engine is solid and working in your implementation. If all of those test cases aren't passing, then your engine's not working, and you need to sit down and debug them, debug issues. And if you have run into any problems, I'll try to help individuals if I can. I'm hoping that this is still useful to you guys. I'm really excited. I can't believe that we're almost 40 videos in. I'll try to do something a little bit extra in the next video. And I look forward to seeing you guys then. Please rate, comment, and subscribe, and we will see you next time.